So far we have talked about the transformations of shifting and reflecting, and we've applied both of those types of transformations in the horizontal direction and the vertical direction. If you remember, our horizontal changes were affecting our x values, and our vertical changes were affecting our y values. Horizontal things were happening inside, and vertical changes were happening on the outside. Well, today, applying the transformation of stretching, we're going to have similar things happening. So let's start with the horizontal distortions first. And a horizontal stretch or a shrink, which we'll talk about the difference of those, happens inside the function, and you're going to see something like f of c times your input of x. So it's a multiplication that's happening. But in order to actually apply this change, you're going to end up dividing your x values, again, x values because it's a horizontal change, by whatever this number is. So we're going to say we have a horizontal stretch if c is between 0 and 1. We're going to have a horizontal shrink if c is greater than 1. So let's think about this from the graphing perspective. If I take a nice parent parabola, we've got our squaring function happening here. A horizontal stretch means it's going to be pulled in the horizontal direction. So my parabola now is going to be much wider. A horizontal shrink is going to be shrinking in horizontally. It's going to become much skinnier. That should be all the way down there. Sorry about that. But now you might be still saying, well, what does that have to do with dividing your x values by c? Well, it all goes back to that parent function of where points are happening. So, for instance, on a parabola, if I were to plot the point 1, 1, that exists on our parent function, which is just x squared. Well, if I take 1/2 of x and square it, my parabola is really 1/4 x squared. So instead of going over 1 up 1, I want to go over 1 and only up 1/4. It's much shorter than it originally was, which is pulling it in the horizontal direction. Whereas if I had c value of, let's say, 2, that should be 2x, and I square it, so again I'm applying 2x and then putting it into this function. Well, that's really the same thing as 4x squared, which means that instead of going over 1 up 1, I'm now going to go over 1 up 4. And my graph becomes much taller, which means it becomes skinnier this way. So if we think about this from a points game, we have the point 1, 1. Our horizontal stretch, we had 1/2. Says divide your x value by that 1/2. Well, I'm going to take my x value, I'm going to take 1 and divide it by 1/2, which really is the same thing as 2, and I haven't changed my y value at all. So the point 2, 1 lies on the graph. That looks pretty accurate. For a horizontal shrink of c, I'm going to take that same x value and I'm going to divide it by 2. Well, that's just 1/2. So now I have the point 1/2. I haven't changed the y value. 1. So 1/2, 1. Right there. This concept is kind of tricky to get a handle on, but as we do more practice problems, you'll see how dividing your x values by c will help you in plotting your graph. The vertical distortions, in my opinion, are much easier. They are ones that happen outside the function, just like our other vertical changes. So we're going to take c times f of x. And we know f of x is the same thing as y, which means that really to apply this change, all you need to do is multiply all of your y values, all of your outputs, by that value c. This is going to go with your intuition. It's a vertical shrink if c is a number between 0 and 1, and it's going to be a vertical stretch if c is greater than 1. So again, looking at a parent function of a parabola, a vertical shrink means that vertically it's going to be pushed down. So our graph is going to be a little bit shorter. A vertical stretch means you're going to be pulling that upwards, kind of like taffy, and it's going to be much taller. So again, if I take the point 1, 1, and let's say our function was, we'll say 4 f of x, so let's multiply the y values by c. So now I'm going to have 0.14, which should result in a vertical stretch because 4 is greater than 1, so 1, 4. If my function were, let's say, 1/4 f of x, I would take my x value, and I'd multiply it, my y value, and I'd multiply it by a fourth, so over 1 and up 1/4. Horizontal affects x, vertical affects y. Let's practice. I just looked and realized I talked for 6 minutes on that last slide. I sincerely apologize. I'm going to try to go through these ones pretty quickly. Make up for some lost time. So I'm going to start with both of these and just graph the parent function. Hopefully with all of your practice in parent functions and our shifting and reflecting, you recognize that we're working with the squaring function. So I'm going to say that our parent function is x squared. And we'll call that, we'll use g of x to represent our parent. That just jumped. So in this first one, I shouldn't use g of x, we already have g of x. This is why sometimes I need a classroom to point these things out to me. We'll say h of x. So in this first one, if I replace x squared with h of x, really I have 2 h of x, which means that I'm multiplying by c on the outside, so this is going to be a vertical change. Because it's a number greater than 1, it's going to be a vertical stretch of 2, which means I take all of my y values for each one of these points, I'm going to take those y values, and I'm going to multiply by 2. So now, I'm going to go 0 and then over 0 times, or up 0 times 2, which is still just 0. I'm going to go over 1, but this time I'm going to go up 2. Over 2, I'm going to go up 8, which is way off my graph. Same thing happening in the negative direction. I'm going to multiply my y value by 2. So I'm just getting that much taller. So now if you notice, my graph got filled in. I paused the video there for a second. I'd like for you to pause, and I want you to try to apply this vertical shrink. I know it's going to be a shrink because that 1/2 is happening outside the function. So go ahead and pause the video. Think about multiplying each one of your y values by 1/2. You can pause now. Alright, a little movie magic, and I have all of my points that have appeared. So I started by plotting the parent points all in purple, and then I multiplied each one of those y values by 1/2. So my graph took a vertical shrink. It was shorter than the black one that's drawn there. So again, vertical happening outside the function affects the y values. So after you have your y values plotted, you can just apply that by multiplying each y value by 1/2 or by 2 in the case of the blue one. Moving on, we get a little bit more complicated because this time we're going to deal with those horizontals, and the horizontals just mess with your head a little bit. So to start out, I have my variable of x, and I am taking that x, I am multiplying it by 3 inside some absolute value bars. So absolute value is going to be my parent function. Then I'm multiplying by a negative, which is going to reflect, and then I am subtracting 1, which is going to shift downward. So to start, let's think about our parent function of an absolute value graph. You should be pretty comfortable with drawing these parent functions and getting some accurate points plotted. So the first thing that I need to do is I need to apply this horizontal change, if you think back to this long slide, our horizontal change says divide all of your x values by c. So that means I need to get my x values for each one of these points, and I need to divide them by 3. So 0 divided by 3, 1 divided by 3, 2 divided by 3, etc. Well, 0 divided by 3 is still just 0. Now I have 1/3, 2/3, it should be a 2, negative 1/3, and negative 2/3. So here's all my new points to plot after applying that horizontal change. Over 2/3 up 2, negative 2/3 up 2. And there's my new graph. These should predict that those should go through 3. So I'm done with this horizontal change. I'm now applying the function, so everything else after that happens outside. This negative sign, because it's outside the function, is going to reflect over the x-axis. So instead of going over 1 and up, or sorry, over 1/3 up 1, I'm going to go over 1/3 down 1, down 2, down 1, down 2. My 0 doesn't reflect at all. So that's applying the reflection. Then the last thing, I'm subtracting 1 after I've applied the function, so after I've gotten my y values. So each one of these y values is going to move down 1. And this right here, not very good at drawing these straight lines. Well, it's going to be close enough. That is your final function, h of x, with all of its transformations applied. Alright, this next one we're going to do kind of together, but you're going to do most of it on your own. It says identify the parent function and the transformed function. Well, first of all, I hope that you can see that this shape right here is a parabola. So our parent function is going to be x squared. And x squared, usually we go over 1 up 1, because 1 squared is 1, and over 2 up 4, because 2 squared is 4. So I want you to pause for a second. I want you to think how this black graph gets transformed into this blue one. Careful about how you're counting on the scale. It's a little bit distorted. So go ahead and pause, think about it, write down your transformation, and then see if you can write an equation for the transformed function. Alright, this one was tricky. There's 2 different ways you can think about it if you want to think vertically or horizontally. So I think the vertical one is easier. You can say that this was a vertical stretch of 4, because now instead of going over 1 and up 1, you're going over 1 and up 4. You've stretched your y values by 4. But then you've definitely moved everything down 8, as you can tell from the vertex being moved down. So you're going to take 4 times the function. I decided to call the function f of x. 4 times the function, and then move it down 8. The other way is to think about a horizontal shrink of a half. So instead of going over 2 and up 4, you're going over 1 and up 4. Down here. So shrinking of a half horizontally, remember you divide by 1/2, which would be the same thing as multiplying by 2. Then apply the function, because this has to happen inside, and then subtract 8. So this is how else you could write it. Either one of these answers would be totally appropriate for a mastery check or a test that's coming up at the end of the unit. Alright, the last task we have for today is taking our graph of f of x and applying these transformations to get a new picture. So to start, we've got multiplying by 2 on the inside, which means you're really going to divide your x values by 2. You are then going to reflect over the y-axis, so this is on the inside. Then you're going to shift down 3. Go ahead and pause your video, see if our graphs match at the end. And the magic of videos, time to see if your graph matches. So I've done everything in colors. The red graph is what matters. That should be your final answer. The green graph represents the the horizontal shrink of 2. The purple represents reflecting, and the red represents moving down. That completes your stretching transformations.